This video is how to identify asymptotes from an equation or from a graph of a hyperbola. Hyperbolas are, I think, one of the most difficult parents that we look at. They have two asymptotes to them. They kind of go crazy in a couple ways. There is one vertical asymptote, straight up and down, and that's where it shoots straight up and straight down. And then there's one horizontal asymptote. The horizontal asymptote, straight left and right, is just like the one for an exponential. So after this, hopefully you'll be able to identify the asymptotes of these two, either from that equation or from the graph here. So let's look at a couple simple examples. I'll have one equation and one graph. Here's an equation of a hyperbola. Y equals 1 over x minus 4 plus 2. Now, if you look at your parent graph toolkit, this is just like the parent graph, which looks like this, except for two things. First of all, the minus 4. Since it's right next to the x, that moves it to the right 4. Remember, it's the opposite of what you expect. So it moves it to the right 4 and up 2. So here's what this equation looks like if you were to graph it. It should look something like this, where it's exactly like the original, except it's moved 1, 2, 3, 4 over, and 1, 2 up. I guess I wanted that to be at 2 right there. Let me erase a bit there. So we'll pretend that this is right at 2 like I wanted it to be. Alright, so again, if you look at your parent graph toolkit, the asymptotes for the black parent equation are x equals 0 and y equals 0. For this one, there's a vertical asymptote right there, and the horizontal asymptote I already wrote in. The vertical asymptote looks like it's pretty close to x equals 4. And the horizontal asymptote looks like it's pretty close to y equals 2. Now I can tell that from the equation that's spot on because it'll always be x equals whatever the h value is and always be y equals whatever the k value is. Alright, now from a graph, here let me make a crude sketch of a graph. So here's an example of an exponential that I'm going to draw in a second here after I get my hash marks in here. These are some of the most difficult to draw because you kind of have to get them right. They're also kind of difficult because a lot of times you can't quite tell from the graph where it's supposed to be going. So there's a hyperbola. What you want to do is look at it and see where do you think the asymptotes are, and whether it's a graph made by hand or by computer, sometimes you have to see what's the best answer. So it looks to me like the horizontal asymptote is somewhere in there. Looks like I bent that a little bit. And the vertical asymptote is somewhere in there. Now, just because of my crude sketch, it's kind of hard to guess here, and I certainly give you some leeway on some of these, but it looks like the horizontal asymptote is somewhere about y equals 2. And the vertical asymptote is somewhere about, well, it's really right in between a couple things, maybe y equals 3.5. And again, I give you some leeway there. If you said x equals negative 3.6, obviously I would not count that. Wrong. All right, a less simple example. Here's an equation, y equals 3 times 1 over minus 17. And let me make a graph here while you're thinking about that one. See if I can make this one a little bit better. Not much, to be sure. Alright, so where are the horizontal and vertical asymptotes? Sometimes I like to actually physically put a piece of paper on there to figure out where it would go. So if I put a piece of paper left to right, the place where I would put it is, you know, about right there. And if I put it horizontally, it'd be, you know, somewhere in there. So those are the two asymptotes. The two asymptotes, as I name them, are x equals -2, because of the vertical one is to the left 2, and the horizontal one is y equals 2. Just a coincidence, those are the same. Going back to the equation example here, this one is 3 times taller because of the 3 out front. The +4 moves it to the left 4, and the -17 moves it down 17. It's always x equals, and then a separate one is y equals for the two asymptotes for this one. It's x equals -4 because it's going to move to the left 4. Remember, x plus 4 actually moves it backwards 4. And it's y equals -17 for the other asymptote. Let me give you a couple examples here. As soon as I've written them down, pause the video and try them on your own. Here's an equation. And a graph. Go ahead and pause the video and try those on your own. Let's go ahead and see how you did. For the first one, for the equation, there should be an x equals and there should be a y equals. There's always both for hyperbolas. Going back, the x plus 5 moves it to the left 5, so there should be an x equals -5 as the vertical asymptote, and then the +4 moves it up 4, so there should be a y equals 4 as the other asymptote. Now for the graph, you kind of have to line up your paper or just try to see it. I'm seeing the asymptotes there and there. So the vertical asymptote is x equals 2. And the horizontal asymptote is y equals, looks like 1 to me. So how did you do? Hopefully you can look at this graph and this equation and identify the asymptotes of those. Remember that there should be 2 for each every time for hyperbola. If you can do it, great. If not, watch the video again or keep working on it in some other way.